To speak with you today, Jigar. I'm looking forward to hearing your views today on the challenges of Industry 4.0. Before we start, can you provide a brief background of yourself?
Sure. First off, Dustin, thank you for having me. Excited to be doing this. So I am a senior director of products at a startup called Falkonry, which is in the space of pattern recognition or AI applied to operations and industrial environments. My experience is I started off as a chip design engineer at AMD, stayed there for a couple of years, had my startups in the SaaS space, was a management consultant at McKinsey for a while. So I've been sort of straddling between corporate and startups, and just recently started at Falkonry. So excited about the industrial IoT space and AI in general.
So you've been a microprocessor design engineer, the co-founder of a SaaS startup in the life sciences space, and then a management consultant with McKinsey, as you were just describing. Can you talk more about what brings you to Falkonry?
Sure. Yeah. So Dustin, before I give you a long twisted answer, let me just cut to the chase and get to the three reasons as to why Falkonry in my case. And this is often a key trait that you'll see with some ex-McKinsey consultants. So number one, the obvious promise. So there's been a lot of buzz about Industry 4.0, the $11 trillion IoT opportunity, the 50 billion connected devices. I mean, you've heard all of that from all the pundits, so I don't want to repeat myself. But then the key takeaway here for me, at least, was that industrial IoT sort of holds the biggest promise, about $4 trillion. So while certainly there is hype and uncertainty, I am convinced personally that we're at the cusp of something big. Number two, I would say, is the geek factor. So I've had the pleasure of being around geeks that sort of bump into glass doors every now and then, but I've also been around buttoned-up professionals who can sort of sell a Lamborghini, while eating it or biting into a donut. I personally feel more comfortable when around geeks, and I've sort of got used to seeing people with bruised foreheads. And I would definitely say that the geek factor at Falkonry sort of hits the roof. I mean, not even the glass doors, the roof, I would say. And number three, the product. So machine learning, pattern recognition, maybe buzzwords, but I was sort of sold when I learned about Falkonry. It all made intuitive sense, and I could connect the dots. So fortunately, my hardware and software background perfectly sort of fit into the Falkonry product journey, and it seemed like the best way to put my engineering product and management consulting experience into practice. So that's the three reasons, and I did end up giving you a long twisted answer. So I guess I was never really cut out to be a management consultant after all, and another reason why I'm here at Falkonry.
Thanks. And in your opinion, what are some of the ways of capturing value from Industry 4.0 applications?
So Dustin, there really isn't a textbook answer for this, and the answer will vary depending on the subject and context at hand. But if I were to generalize, I would say primarily four things. There's digital enablement, there's automation, let's say number three would be throughput optimization, and finally predictive maintenance. Now, if I were to go through each one of those, starting with digital enablement, in my opinion, providing a digital gateway to manufacturing sort of helps accelerate existing lean processes. It helps to build a data-driven mindset and hence sort of lays the foundation for more advanced technologies that in turn sort of pave the way for efficiencies and optimizations needed for Industry 4.0 to succeed. Digital dashboards, for example, help support performance analysis to achieve OE improvement by increasing engagement, not only of the frontline operators, but also the management. People often don't realize that performance data usually persists beyond the shop floor whiteboard. It manifests and supports normalized calculations and reporting. It allows KPIs across previously siloed functions, plants, and business units to be shared and benchmark for consistency, and also allows for best practice sharing. For number two, I would say an automation. When we talk about automation, we imagine robots taking over the floor, sort of displacing humans. Yes, for sure, we can expect and we should expect a significant adoption of robots on factory floors. And this trend is expected to accelerate further because of the advances being made in one, sensing the data, and hence the buzz on sensors, and number two, making sense of the data, which leads us to the discussion of artificial intelligence. So it's not just the invasion of robots and automation on the factory floors. Automation actually helps us in a lot of other areas, such as decision making, resource allocation, demand forecasting, order management, etc. For number three, throughput optimization. Factories stay competitive by maximizing throughput and managing the costs. So the digitized data that we spoke of just a little before can be used for process control systems to optimize yield. But now in manufacturing operations, a lot of operational intelligence is characterized by time series data that often stays hidden from the users. So identifying bottlenecks or processes that are largely responsible for impacting quality, or for that matter, levers that impact the yield, are really hard to decipher for the human. And throwing the right technologies to get a better real-time measure of operational efficiency can hence lead to thus higher throughput and higher profits. Finally, predictive maintenance. Usually when we talk about predictive maintenance, it's geared to see sort of an increase in machine availability and a reduction in maintenance costs based on the introduction of new predictive maintenance algorithms. Companies, in my opinion, need three components to be successful as far as predictive maintenance is concerned. First of all, you need sort of knowledge of the respective assets itself. Number two would be strong analytics or advanced analytics know-how, such as machine learning. And finally, the appropriate change management capabilities to actuate this knowledge into action. So if you notice across all these four, these capabilities are not orthogonal to each other in any sense. For example, digital enablement leads to predictive maintenance, which sort of in turn leads to throughput optimization. On the other hand, automation is needed to ensure scalability of all these capabilities. But then the takeaway here is that a disciplined, data-driven, and measured approach are the key enablers to Industry 4.0.
Well, you mentioned Industry 4.0 and the buzz. So where do you see some of the challenges?
Yeah, so Industry 4.0 has raised definitely high expectations, and I definitely would say that not all have been met yet. There's definitely the buzz is primarily around operations optimization, predictive maintenance, inventory optimization, health and safety, you name it. Not all of which can be measured easily in terms of expectations and measures of success. Everyone wants a magic wand, but Industry 4.0 implementation is a sort of multi-year process, and more applications will develop as technologies mature further. So it is imperative that manufacturers across the world with a set of concrete applications. There's also a degree of disillusionment in the actual implementation, and the results so far are mixed. Like, for example, on one hand, we still see high uncertainty among manufacturers regarding implementing their 4.0 strategies and what's really required of them. And many are struggling to even get started. Well, on the other, there are technology suppliers that have moved relatively fast in adjusting for Industry 4.0. So very few technology providers and manufacturers have an overall strategy in place, and even fewer have assigned clear responsibilities and goals. Industry 4.0 requires a plethora of technology requirements, both IT side and the OT side. And whenever you have a confluence of varied technology stacks, you can easily find yourself, in implementation mayhem, where half-baked solutions are often very patchy, and in hindsight, the solution stack is not really scalable and portable. I've come across many situations where executives are driving 4.0 strategies or Industry 4.0 strategies without really understanding and appreciating the nuances and limitations of, say for example, machine learning, big data, OT/IT protocols, connectivity standards, etc. And I can give you an example where executives often clamor for just more data and throw resources at big data technologies. But often big data is just more dumb data than with very little contextualization. And the secret lies in marrying the human experience with some algorithmic power to identify patterns that are more conclusive, useful, and hence more actionable.
Well, I guess you're heading somewhere with this. But how do you think Falkonry fits the bill here?
Yeah, sure. But before I get started again, let's just dig a little deeper into the motivation. Peter Thiel, in his book From Zero to One, picks up on an interesting discussion. There's this ominous outlook and concern of AI and machines taking over the world, with humans being replaced from their jobs and Skynet beaming humans out of existence. I mean, this all calls for some interesting science fiction, but he does cite several examples where human skills are complementary to opportunities that can be enabled through computers and AI. Machines might as well, can toss gigabytes around, but they really aren't really that great at making judgments. And a good case in point is the fact that you can train a model to recognize cats with 90% accuracy after scrumming through, say, thousands of training images. But if you think about it, that's something that a 4-year-old can do easily. So then coming back to Falkonry, I think Falkonry builds up on this premise where Falkonry uses advanced digital signal processing and machine learning techniques to identify temporal patterns in time series data. But the data gets really enriched when a subject matter expert annotates his experience on top of those temporal patterns. With a more contextual perspective to these patterns, it suddenly makes much more sense. So thus Falkonry is a tool for subject matter experts, a tool that empowers them to cut the cord of dependence on data scientists and programmers that work in their own bubble. It also does help minimize the context that is lost in translation and humans talk to each other, and instead provides a paintbrush for the subject matter experts themselves to paint the scenario such that they understand the operational data best. So to sum it up, I think the answer lies in the fact that it would be misleading to look for an all-encompassing solution that works as a magic wand, a wand that would minimize human interaction and propel us into an automated world of connected devices that make smart decisions. I think what's really needed is a way to equip, enhance, and complement the human judgment with better data-enabled decision makers. And in my belief, I think that's Falkonry, and that's what Falkonry brings to the Industry 4.0 challenge.
And thanks for sharing today.
Great. Thank you, Dustin. Appreciate the help.